Okay, in this video we're going to go over composition of functions. So in composition of functions, to start, we're just going to go over what composition means. But it's basically we're going to substitute a value into another equation to make a new equation, or to have a new value. So it's similar to the substitution technique we did when we solved systems of equations, which was a couple months ago now due to all our breaks. But it was towards the end of November. So number 1 says f of x equals 3x plus 1, and we want to find what is f of 2. So 2 is inside the parentheses, which means I'm going to put that value inside of f of x. So when I have f of x, if I'm trying to find f of 2, everywhere I see an x, I'm going to put a 2. So to find f of 2, I'm going to replace every x with a 2. Then I solve. So 3 times 2 is 6. So f of 2 equals 7. So we take the value that's inside, whatever's inside the parentheses, and we put it inside whatever function is outside. In this case, there's an f, so we put the 2 inside the function f. Okay. So now we have f of x equals 2x minus 1, g of x equals x squared minus 4x plus 3, and it tells us to find f of g of 2. So we're going to start in the very, very inside of our parentheses. So in the farthest inside is g of 2. So first I have to find g of 2. And from our previous example, to find g of 2, everywhere I see an x in the function g, I'm going to put a 2. So instead of x, I'm going to write the new input, which is 2. And to solve, I get 4 minus 8 plus 3, negative 4 plus 3, which is negative 1. So to start to find f of g of 2, I find g of 2, which is negative 1. Then I take that value and I plug it, I substitute that into f. So f of negative 1 is 2, negative 1 minus 1, which is negative 2 minus 1, which is negative 3. So after we do all this, we first found g of 2, because that's what's in the farthest inside. Then we found f of negative 1, because g of 2 equaled negative 1, and f of negative 1 equaled negative 3. So f of g of 2 equals negative 3. So you take what's inside the parentheses and plug it into the function it's assigned to. So we plug 2 into g and got negative 1. Then we take that value and plug it into f, because that's the function on the outside. So you start inside parentheses and work your way out. Here's an example that doesn't have numbers. If you notice, it's f of g still, but instead of g of 2 or g of some number, I just have g of x. So if I want to find f of g, or f composed with g, I'm going to take the function g of x, and I'm going to put it inside the function x. So instead of having the function f and inputting a number into the equation, I'm going to take the function f and I'm going to input the function g. So to do that, so f of g of x is I take the function f, and everywhere I see an x, instead of putting a number like I've been doing, I'm going to put the function g. So I had the function f of x, I copied down, and then instead of an x, which I had in the original f of x, I put what g is. So instead of the input being x, now it's x plus 4, which is g of x. So now I need to distribute. So I have 3x plus 12 minus 7, which equals 3x minus, ooh gosh, I lied. It equals 3x plus 5. So to find f of g of x, you take the function g of x and you plug that in to f. So f was originally 3x minus 7, and g of x was x plus 4. So I took the function g of x, which was x plus 4, and I plugged it into the function f, which was 3x minus 7. So instead of 3x minus 7, I have 3x plus 4 minus 7, because I plugged g in for that x. Alright, I know I said f and g of x probably 10,000 times right there. Hopefully my work you can follow. Like always, we'll do a couple examples in class, and then we'll practice on our own. Alright, see you all in class tomorrow.